Here he is again. Yeah, summer break because of the heat. Summer has its good and its beautiful sides. Sometimes it was a bit too warm for me, and besides, I had things to do in the garden. So I took a somewhat longer break. Now I'm back, and the topic is photovoltaics. Today, solar trackers. I have a small solar tracker. I've already tried several times to build a solar tracker myself, especially for the winter. It was supposed to give me a bit more efficiency and basically make up for what the sun doesn't provide. And in the process, I came across a very interesting little device that actually looks like a toy, but it's got a lot going on inside. And one more thing. By the way, I want to thank all my subscribers. Now, on my super tiny little channel, I have over 300 subscribers. So thank you very much for sticking with me. After a bit of a longer break, here it is again, another video. I bought myself a dual-axis solar tracker. It may look like a toy, but it definitely isn't. This little thing is actually better than you might expect. Just like you see here, I got it on AliExpress for a pretty reasonable price. The tracker itself is well, I'd say it's a bit decorative. But the controller is something else. It's really good and can be used universally. You can use it for geared motors or for linear actuators, so it fits just about anywhere, and that's what I want to show you. Just a quick explanation. I've mounted a small 20-watt solar panel on top here. Then there's a moped battery, a 12-volt moped battery, connected. I've hooked it up with a small charge controller. That's in the gray box. I'll show you that again later. But for now, I'll just let the thing run on its own. Let it run. The whole kit you get also includes this wind sensor. And like I said, the controller, which is actually great and universal. I've always had the idea of getting myself a solar tracker. No, not getting one, but actually building one myself, because I wanted it to help compensate a bit in the winter for the lower yield. So the yield should be balanced out a little. And I thought, well, a solar tracker could maybe give me another 200 or 300 watts, even on bad days. Which, yeah, I wanted to. And if possible, I wanted to do it without a big foundation. Everything was supposed to be made from leftover materials. So basically, parts one already had. And I also imagined that I might take the whole thing down again in the summer, because it might get in the way somewhere. As you can see here, I've covered its eyes for now. There are 4 small sensors inside. They're connected in a crisscross pattern with an operational amplifier. And it performs what's called a zero-sum measurement. That means if it measures 0 across the diagonal, it's perfectly aligned. The great thing about this part is that it really only works with this sensor. You just have to install the sensor in the right spot. That means it has to be installed in a north-south direction, right at the top. And then it basically aligns itself automatically. All the swivel ranges are simply programmed by just taking one measurement and then over time. So it's actually really easy to do. Like I said, I tied it up at the top for now. And I'll take it off in a second, and then it'll move into its working position. You'll see how that works. And you just have to imagine, this is just a little demo. So it really doesn't matter if you do this on the big ones. For example, the exact same control system is used on the Ecoversi. So it's exactly the same control system. The Ecoversi is actually the tracker that's currently, and is pretty easy to find on YouTube and online. And it works really well too. But it was just a bit too big for me. That was my problem. And I wanted to do something a bit more custom, especially since I already have 3 different projects that basically work the same way. Some of them started out made of wood, and then there are a few other things too. I'll show you those, but a bit later. Those are just a few pictures. The important thing is, and you should know this, it fits, always with this control system attached. Super simple. Like I said, originally I was planning to do this and would have used an Arduino or an especially, and I would have just controlled the thing with that. But with this control system, you basically have everything you need. You have a wind sensor, relay control, a display, the buttons for it, and even a matching case. I just have to say, respect. So for me, this was a real bargain. Here you can see again, it's aligning itself, and in a moment, I filmed it going to sleep again. This is just to show how it works. And you just have to ignore this little part and just tell yourself it could be a really big one too, because it's exactly the same control system. Now you can see this is in the evening. You set the intensity, and when it gets too dark, it goes to sleep. That means it moves into the good morning position and lies flat, so that in case of wind, there are no problems. And that's how it works. I've been testing it like this for about 14 days now, so it works without any issues. Okay, next we'll disassemble the control unit, and I'll show you a little bit about how it's connected. So this is the complete package that I ordered again from AliExpress. The price included all components. What one can imagine, approximately 72 euros. Arrived within 8 days compared to AliExpress. Yes, let's see. Let's unpack it. As I said, I've already made a very rough start. This is the wind sensor. Let's set that aside for now. I'll show it to you in detail later. And here is basically everything you need. Remote control? Yeah, I haven't even put the battery in the other one. I'm not sure what exactly you'd want to do with the remote, but in any case, a remote control is included. This is what the whole thing looks like. I'll set the remote control aside for now too. This is already permanently attached. The solar sensor, so that's this one, and you need to remember this in a moment. Please, it always needs to face south. That's really important. If it's turned the wrong way, it won't work properly. So whenever you attach it, always make sure it's facing south. All right, now I'll take this out first. I also recommend, and I'll show this again at the end, I'm just going to set this down here like this for now. It's best to use connectors for everything. That's what I did with the other one too, except there I only had 8 or 9 pin connectors. Here we only need a 4-pin one, but I had already ordered that. I had already removed 2 screws, so this doesn't take forever. And here we have everything we need. So then you just take this off. Let's turn this on again. This is important here because this is the connector for 2 axles. There's also a single axle connector. So be careful on eBay. What's cheaper is usually just a single axle connector or a single axle control unit. Otherwise, it also says here that it's from 10 to 28 volts. I'm not completely sure. I read it in the user manual. By the way, I translated the manual again and I'll make it available for download on my website. But I'm just not completely sure if it can really handle 28 volts and maybe also switch 24-volt actuators. I haven't figured it out yet, but I'm working on it. That's what it looks like. I'll just set this aside for now. And then here, I need to raise it up a bit. Let's do it like this. Then up here we have the display, the setting buttons, the 4 relays. Right here is exactly where the sun sensor, which is that PV sensor I just showed you a moment ago, is actually connected to the system. This is where the wind sensor goes, and here is where the motors are connected. And here in the middle is the 12 volts. Over here is the connection for the inductive proximity sensors. These are needed if the actuators don't have their own switches. You'd need them, for example, if you're working with a geared motor and have a half-toothed gear segment, and then you'd use them for that. You can control it that way, but there are other ways to do it too. But I also have everything here to show what else you might need. Here's my fuse in the middle, and that's really all there is to it. So there's not much you can do wrong. The wind sensor is connected here, the two on the right. Then here we have west-east, that's the west-east motor, and this is the north-south motor. So north-south is this one, if you look at it like this, and west-east is the one that rotates. And here is the input voltage. That's basically all there is to say for how. Now I'm going to get the other control unit, show the wiring again, and then we'll program it. Like I said, that's also pretty simple. All right. So now I'll show you my wiring, how I did it. By the way, I think I need to correct myself. Earlier I said there were only 4, but there are actually 5. It's the solar sensor, so the cross sensor has 1, 2, 3, 4, 5 connections. And it has red, white, yellow, green, and black. I would recommend separating it here and doing it with a connector so you can completely remove it if needed. The whole story, unfortunately, I didn't have the right connector, but I've ordered one because this one is big and this one is too small. So that's how I would do it. The next thing would be the wind sensor. The wind sensor, it's 2-pole, basically just a small dynamo, and it actually just measures a voltage. That's why there's the blue one here. What I have left over is I attached a connector like this, wired all the way to the right, and the middle and far left are not connected. So even though it's a 3-pin connector here, only 2 pins are actually used. Whether there's a correct orientation, you'll have to try it out. Whether it's plus or minus, you'll see when you test it. I think I checked with the multimeter and it was in the right order. Here it says once. And once, just wind. So you really can't make out much here. All the way on the outside, it's V plus again. So I think that the right side is plus and the left, no, that the middle is plus and the right is the signal, the second pin. That should actually work. I just go with the idea that where I have the red wire, that's also plus. You can easily check that with a multimeter. And that's how I would wire it up. Sometimes it's not all that clear. All right. Now comes the most important thing, voltage. I'm going to leave the other 2 motors out for now. I'll just set them over here. I used a barrel connector, like this one. I can connect it to a regular power supply, like this one here. Or also to the battery. Now, the question is, why the battery? You need a buffer. If there's no buffer and there's no light on the solar cell, it won't work. And that's why I came up with this solution, with the small 12-volt battery. There are other ways to do it too. With larger panels, you can just hook up a charger and say, I'll draw my voltage from there. Or you can use a power supply. But honestly, I don't think the solution with the battery is that dumb. It's actually pretty practical. We can just have it right here. So then I have a little charger from above, basically from the panel, and that always charges the battery. It's for 12 volts and it charges a regular lead-acid battery. I should also mention something else to you. That little panel you saw there, the one I attached only has 22 volts. So it's just right, because that works. But if you want to connect it to a big panel with 36 or 42 volts, you should only use up to 28 volts. You'd need to step it down a bit first. Using a step-down device or a step-down module, you basically bring it down to 24 volts because it can only handle a maximum of 28. so you need to step it down beforehand, but you can decide how you want to do that. Earlier, I also forgot to mention, up here, this is the sensor for the remote control. So we've got voltage, and now, basically, it's just these two motors left. I use these connectors for. I think these connectors can handle 20 amps, so you can hook up a bit more of them. They come from Model Building, and the exact name is XT60. They work pretty well for this. They're basically connected to the servo motors. And that way, you can just plug them in easily for the kids, for the inductive proximity sensors. They look like this. They're not. I actually ordered some extra ones, just in case, because I wasn't sure whether I might end up using them at some point. If I ever build a bigger setup with a geared motor, they'll be wired up back here. But honestly, it's not a big deal. It's also explained in the manual, but like I said, you don't really need them, because in most cases, most motors already have everything you need. The lift motors, or you can also do it directly, like in this little demo setup here, have limit switches attached. You can adjust and set them up there. All right, so that's basically just the wiring part. As you can see, there's really not much to it. And now let's move on to the programming part, what still needs to be done there. Like I said, I recommend a small battery and a small charging module. That way, you can also run bigger motors, like those that draw 3 amps off the battery. It'll easily supply 12 volts at 3 amps, no problem for the battery, and that way you're always on the safe side. There are definitely a few other options out there, but for now, I just went with this setup. And I'm going to try it out with the project I'm finishing up now and plan to use over the winter. All right, now let's move on. That's a good transition. Let's talk about programming. I came up with something that I think I can explain pretty simply, and it actually makes sense. Before you even begin the process of programming your system, first drive the north-south direction mechanism all the way to the north until it comes to a complete stop. And then carefully measure the total time in seconds that it takes until it finally hits the very end of the track. Then do the same going south. Do the same for the west-east direction. Drive all the way west, then drive back. Using these buttons here. And then drive back and measure the time. Please write down both times. All right, now let's move on to the basic setup. Let's put this on toggle gear. And I'll start from the back. Set V3. Hold on. Set D3. V1 is the precision. I set it to 0.05. That means this is the sensitivity. V2 is the speed limit. You have to figure that out yourself. So I set it to 60 or 0.6 volts. You'd have to turn it and maybe figure it out. How windy is it? Yeah, that's how it works. And V3 is basically sleep mode. Sunshine limit. That means if it goes below 1 volt, so it's actually pretty generous. You could definitely set it lower. If it goes below 1 at that specific voltage level, then it would gradually start to want to enter its sleep mode. And now let's continue. These preset values are basically the basis for the settings now. Press down. So I set the north-south reaction time to 70 seconds. Wait, let me go back again. I'm probably wrong. East-west reaction time, 60 seconds. This is simply about when there's any change in precision, meaning sensitivity, it always takes 70 seconds for it to react. This is to prevent the controller from starting to oscillate, meaning it doesn't react back and forth too quickly. North-south time. All right. Wind to east. That means we had set it to 60 millivolts. How should it react if it's below? If the wind comes from that direction. But I never actually configured those settings myself. And it is exactly the same situation for shifting the direction of the wind to the west, or even setting the wind to the north. Wind to south. So basically, you can set it up so that if the wind gets too strong, it turns either to the north, south, or west direction. And now we know how many seconds it takes. It needs to reach the end position, and we just enter those seconds there. That means if the wind is too strong, for example, we just say it turns toward the north. And so that it basically becomes vertical, meaning it lies flat, and then the wind can't really do much anymore. That's basically how it's intended to work. And here you have wind, fixed, lock time, wind. So that means if the wind speed is exceeded, and it lies down or basically moves into a wind-sheltered position, let's say, like this, then it's blocked for 600 seconds before it can even react again. So, waiting time, sun low delay. If it drops below the sleep setting, meaning the limit, if it basically gets too dark, it waits. Here, you set just a moment. You set 180 seconds here. And then it starts to turn in the direction we've set here. So it should turn toward the east, and that's what I set up above, 50 seconds. So it turns. When it gets too dark, toward the east for 50 seconds. Not toward the west, it shouldn't turn that way. And toward the north for 25 seconds. That means it also tilts back a little bit. And that's basically how it stands for the morning. Exactly facing east, slightly tilted. And that's basically how all the settings work. Sun low to south, meaning it doesn't need to turn south when it gets dark. And recover time, now it takes 10 seconds until it basically jumps back to the normal menu and starts running again. That's really the whole science behind it. So really, you just need to set those 3 things beforehand, and then tell it what to do if any of those things fall below or exceed the set values. If the wind exceeds the limit, add dusk. Or if the light intensity gets too low, where it should turn to and where it should go into sleep mode. That's basically it. At the end, you just press Quiv here. Then it saves, which takes a moment, and after that, it starts running again. That's basically it for the programming part for now. All right. So, actually, this video turned out to be longer than I expected. I'll definitely make a second part. In the meantime, you can write any questions you have in the comments. And next, I'll install the new controller on the slightly larger model. So this is a model, the one I placed in the submail at the front on the right side. It's really just a functional prototype, but it should work just fine. As I said, feel free to leave comments or questions. The second part will definitely be interesting as well. And I'd really appreciate it if you could give me a like every now and then, or maybe even subscribe. That really helps me out a lot. I'm already over 300 subscribers, so thank you all very much. See you soon.